Welcome to the Nokia SR Linux Learning Essentials video series, brought to you by the Nokia Data Center Fabric Certification Program. This video explains how to configure ISIS as the underlay routing protocol on the SR Linux router. ISIS is a link state routing protocol. Routers running ISIS exchange topology and IP reachability information with each other and maintain an identical copy of the network topology. Each router then uses the shortest path first, or SPF algorithm, to determine the best path to reach every other router, and consequently the subnets attached to them. The best path is defined as the one for which the sum of link costs is minimum. In ISIS, the default cost of a link, no matter its bandwidth, is 10. This default behavior can be modified by configuring a link cost value or specifying a reference bandwidth. Leaf1 is pre-configured with a MAC VRF that interconnects hosts 10, 11, and 12. An IRB interface connects the MAC VRF to the network instance default. Spine1, Spine2, and Leaf2 routers are all pre-configured for ISIS area 49.0001. All interfaces interconnecting the Spine and Leaf routers are configured as point-to-point. Leaf2 is advertising host 20's IP network 192.168.201.0/30 to both Spine routers. We're going to configure ISIS in the network instance default on Leaf1. We will put all of the interfaces on Leaf1 into ISIS area 49.0001. Those are the two physical sub-interfaces that connect Leaf1 to Spine1 and Spine2. The loopback sub-interface on Leaf1, whose IP address we will use when configuring the system ID. Finally, the IRB interface that connects hosts 10, 11, and 12 to the network instance default. Once completed, host 10 will be able to ping host 20. Let's go to Leaf1 and navigate to network instance default. When we check the interfaces, we should see the two physical interfaces that are used to connect Leaf1 to the two Spine routers. We should see the IRB interface that interconnects the MAC VRF network instance to the network instance default, and we should see a loopback interface. All four of these interfaces should be operationally up. Next, let's look at the routing table. Here we see the 5 local host addresses, as well as the 3 local network addresses. This shows that there is no routing protocol operating in the network instance default on Leaf1. Next, let's go to host 10 and try to ping host 20's IP address. The ping fails since Leaf1, as we saw, does not have a route to the network of host 20. Let's configure ISIS. First, we'll enter into the candidate mode and navigate to protocol ISIS. We will define an instance 1 and set the admin state of the instance to enable. Next, we'll set the network entity title or net to 49.0001.1000.0000.2001.00. The net identifies the area and system ID of the router. We'll set the level capability to L2. Next, we'll add in the interfaces. First, the interface to Spine1, and we set the circuit type as point-to-point. Next, the interface to Spine2, again the circuit type is set to point-to-point. Now the loopback interface. Since the loopback interface is a virtual interface, we'll set it to passive. Finally, the IRB interface. We'll leave it at the default type of broadcast, but we'll also set it as passive since there are no routers in the NAC ERF. We will use the info command to verify our configuration. If satisfied, use the commit stay command to commit the changes and stay in the ISIS context. To verify ISIS operation, we'll look at our ISIS adjacency status. Leaf 1 should have the two adjacencies, one to spine 1 and one to spine 2. The adjacency level should be L2 and the state should be up for both spine 1 and spine 2. Next, we'll look at the database for ISIS LSPs. We should see LSPs from all four routers: spine 1, spine 2, leaf 1, and leaf 2. Next, let's look at leaf 1's route table again. We now see multiple networks being populated into the route table using ISIS. The one that is of interest to us is the 192.168.201.0/30 network, as this is the network IP address of host 20. Let's go back to host 10 and try to ping host 20's IP address again. This time the ping is successful. That's it for SR Linux ISIS configuration and verification. Thanks for watching, and be sure to explore the rest of this video series to learn more. And when you're ready to practice what you've learned, my DCF Learning Labs provides comprehensive exercises with step-by-step instructions and solutions, all in one simple browser-based application.